All right, so this video is about expanding logarithms. I know that there's a lot of different textbooks and things out there that would explain two different reasons why we expand logarithms. And I mean, there's knowing the properties, but I like applying the properties for specific intentions. So, for example, if I had let's say I had like log base 3 of 30 squared, okay? You could just say, oh, okay, well, I'm going to break this down. And the way that you break it down, the first thing I would do is you can move exponents to the front of a logarithm. And so that I would have 2 log base 3 of 30. Then from here, I would break down 30 into 2 different numbers. Okay? And the intention of why I'm doing that is because I have a base 3. And if I have a base 3, I want to try to make this logarithm as simple as possible. So what if I broke this down into 2 different pieces, such as 2 log base 3 of 3 and 2 log base 3 of 10. Because, as we know, 3 times 10 equals 30, right? So 3 times 10 equals 30. That's how I can break it apart. And the whole goal of what I'm trying to do here is, see how I have log base 3 of 3? If I'm in that situation, or if I have that, that becomes 1. Because 3 to what power equals 3? 3 to the first power equals 3. So that is why log base 3 of 3 becomes 1. And then I simply have 2 times 1 there, which is 2. Then, whatever I get there, I have to add to the other side, okay? And now log base 3 of 10 is I would have to have a calculator, or I would have to be given certain logarithms to know what log base 3 of 10 would be. So enter in this kind of problem, where, again, it says use the property of logarithms to find the value of that logarithm without using a calculator. Okay, so we have to try to find out or evaluate what log base 7 of 99 is. We have to try to figure out what it is without using a calculator. Okay, but like I just explained, what if I could split this up? Let's see, I'm given these 3, right? I'm given log base 7 of 11 equals 1.2, log base 7 of 12 is 1.3, and log base 7 of 9 is 1.1. So what if I could split 99 up using one of those 2 numbers, right? So using one of those 2 numbers, well, I think 9 times 11 is 99, right? So I can make this log base 7 of 9 plus log base 7 of 11. Right? Because if we do the work here, 9 times 11 equals 99. That's the goal. So, and look here, log base 7 of 9 is 1.1. Okay, so 1.1 plus, and log base 7 of 11 is 1.2. And, of course, you know how to solve this on a calculator, but on standardized tests and other tests that I'm going to give you, you may not get a calculator, and you have to know how to break it down using just the properties of logarithms. So the key is that you can split apart a logarithm as many times as you want, of course, until you have all prime numbers. But the goal of it being, you can break it apart using its factors. So the factors of 99 are 1 and 99 and 9 and 11. And luckily, we knew what log base 7 9 was and log base 7 11 were. So you were able to do it that way. So, again, that was all without a calculator because they gave me what those logarithms were. Okay? And in the same way, we could also look at this using a division problem. So if I had like log base 3 of 1 over 3. Okay? So if I have a fraction involved, and so when I split it up into 2 different factors, it was multiplication, meaning I added the logarithms together. When I'm dividing, I'm actually going to subtract the logarithms from each other. Okay, so log base 3 of 1/3, I can split this up into 2 different ones. So I'd have log base 3 of 1 and log base 3 of 3. And since it was a division problem, I need to subtract those logarithms from each other. Okay, and if I were to change log base 3 of 1 into a exponential form. Again, 3 to what power equals 1? Well, any number to the 0th power equals 1, so log base 3 of 1 equals 0. And as we talked about before, 3 and 3, so log base 3 of 3 equals 1. So 0 minus 1 equals negative 1. So that answer is negative 1. I didn't need a calculator for that. But I wanted to show you that when you're dividing, you subtract the two exponents. So enter this problem, number 3. Okay, so on number 3, all right, so I have 1 over 100. So my recommendation would be, let's change this to log base 6 of 1 minus log base 6 of 100, right? Okay, but you'll say, wait, Mr. Schwant, I don't see log base 6 of 100 there. What do I do? Well, can I break log of 100 down into log base 6 of 10 plus log base 6 of 10, right? I can break that down to that, and then I still have minus, so I add those together, and I still have minus log base 6 of 1. And now I also know what you're saying. Wait, Mr. Schwan, I don't see log base 6 of 1. Well, let's think about it. Any logarithm that any base of 1 is going to be 0, right? Because if I were to rewrite this, 6 to what power equals 1, excuse me. 6 to what power equals 1? Well, 6 to the 0th power equals 1. So that all equals 0. Okay. Minus. And then log base 6 of 10, that's given to me right here. So it's 1.3 plus 1.3, which that's 2.6. So 0 minus 2.6 is just negative 2.6. So that's my answer there. Okay? And so that's the purpose of why we expand. And later on we're going to talk about condensing logarithms, but we do it for the intention of trying to evaluate logarithms without a calculator. And just kind of uses logic, like how can I break this number down so that I can use the information given to me. So that is how we evaluate logarithms when I can't use a calculator. Again, if you try to confirm in your calculator, of course you're going to get it. But on tests, you're going to see things like this where you can't use a calculator. So I wanted to show you that way. So there you go.